Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, we are going to start our course Analysis of Structure. In Analysis of Structures, what kind of analysis we are going to done in structures? What type of parameters are involved in this particular structures? We are going to understand in this particular course. So, in this analysis of structure, in two ways, for new construction works as well as already constructed ones. So, already constructed structures, we are going to analyze those structures, as well as for getting the better design, we are analyzing the upcoming structures also. So, in this, we have and different types of syllabus we have, that is arches. In these arches, we are understanding what is meant by arches, what are the various types are involved. In between these types, how we are going to compare those types of arches, in that what are the various parameters involved in that particular arches based on the geometric properties, but based on the types of arches, how we are understand in each type, how we will get their properties. So, these are all the parameters which we are going to understand in our module 1, that is arches. In module 2, analysis of indeterminate structures. So, whenever move on to the in detail lectures, we will understand what is meant by determinate structure, what is meant by indeterminate structure. So, here our module 2 is indeterminate structure. How we are analyze the indeterminate structures using the theorems. Various theorems we are using for understanding the structure. We are using for the analysis of structures. And one more, module 3 is we are using slope deflection and moment distribution methods for understanding the analysis. How we are derive these slope deflection equations as well as moment distribution equations. How we are applying, which type of structures we are applying these kind of theorems. What is the process involved in each and every structure using these methods, that is slope deflection method and moment distribution method. Canis method. So, this is another method. So, according to the various methods, it is adopted for different kind of structures. So, depend upon the type of structures, we are choosing the which method gives the better understanding and better analysis. So, according to that, we are going to choose the methods. So, in this module 4, what we are understanding, that is Canis method. So, we are introducing this Canis method, how it is works, what are the various terminology in this particular Canis method, how we are applying this Canis method to the structures, analyzing the structures, what kind of structures are adopted for this Canis method. These are all the parameters which we are going to understand in this module 4. In module 5, moving loads and influence lines. So, in this particular, we are understanding the moving loads, how they are influencing the parameters, the shear force, bending moment under various loading conditions. 2-point loads or otherwise concentrated load, are uniformly distributed load, various conditions of these loading, whenever they are moving, how the influence lines are we are getting. So, from this we are understanding the shear force and bending moment at given sections and their absolute maximum shear force and bending moment due to the various load conditions. Those are moving loads. So, in this particular chapter, we are understanding the under various load conditions, these moving loads, how their influence lines we are getting for the maximum shear force and bending moment in this module 5. These are the overall modules we have in this particular analysis of structures. In this analysis of structures, according to this end of the course, we are going to understand we are going to get these are the course outcomes we are going to expected. So the one is course 1 CO1 course outcome. That is course outcome 1. Outline about various types of arches for selecting appropriate arch in the field of applications. Here, based on the type of the arch, for selecting appropriate arch in the field application. So, for applying what type of arch is suitable in practical scenarios, we will understand. So, we will get this understanding as per the module 1. So, we are going to, this is the one of the outcome we are expecting from this course. In course outcome 2, make use of energy principle in the analysis of two hinged arches for computing the resultant thrust and evaluating secondary stresses due to the thermal and rib shortening effects. Coming to the CO3, apply the concept of Castiglione's theorem for analyzing the indeterminate trusses. Course outcome 4, analyze the continuous beam using the concept of slope deflection and also moment distribution methods and Canis method for design rigid frames with and without side sway. Coming to the course outcome 5, summarize the effects of rolling loads for through understanding of the variation in internal forces on bridge girders due to moving vehicular loads. Coming to the course outcome 6, apply the concept of influence line diagrams for analyzing beams, bridges, bridge girders and trusses in real-time problems. These are the various outcomes which are involved in this particular course for the given modules 5, various different module 5. So, end of the course we are going to, the students should be able to understand all this, get these course outcomes. This is the overall overview about the course. In this particular lecture, we are talking about the introduction to arches. Introduction to arches. In this introduction to arches, first we have to understand the structural analysis. So, what is meant by structural analysis? Why it is required? What are the terms involved in this particular structural analysis? So, a structure, it is relates to the civil engineering. It is a system of interconnecting members. We know thus beams are connected with columns, and these beams and columns, they are again connected with the slab. So, some individual elements are there. Those elements are connected with some point. So, at that particular point and the combination of all these elements is nothing but a structure. So, whenever this structure, whenever we apply some sort of loads, how it is behave as per the loading condition, this is nothing but the structural analysis. It is the prediction of the response of structures specific arbitrary external loads based on the external loads, whether it is maybe point load, whether it is maybe uniformly distributed load or uniformly varying distributed load. It depends upon the type of load and how that particular element is going to respond. That is nothing but the structural analysis. So, the prediction of the response of structures to specific arbitrary external loads. During the preliminary structural design stage, whenever we are going to design any kind of structure, this structural potential external load is estimated and the size of the structure's interconnected members are determined based on the estimated loads. Dead load, live loads, wind loads, so many different types of loads are present, or they are ready to give some stresses to the particular element or structure. So, in this, for how much size of the beam is bear for the particular load. For example, some load W is there. So, according to that, how we are decide the size of the beam or column. These are the various elements or slabs and etc. So, how they are bear these kind of load for them together as a structure or together as an individual element. So, in that particular, we are going to understand, according to that, we are going to design the size of the beam or size of the column or size of the slabs. So how it withstands. So these are the things we are going to understand in this structural analysis. At the time of structural design stage, a structure's potential external load is estimated and the size of the structures. So for example, beam size, column size, slab size. So we are going to understand. Further, we are giving the design. So interconnected members are determined based on the estimated loads. So here, this structural analysis establishes the relationship between the structural members, expected external load, and the structures corresponding developed internal stresses and displacements that occur within the member when in service. Here, for example, the beam which has some different sizes, and based on the material what we are used, the mixed proportion, whether it is maybe M30, M20 grade of mixed proportion we may use. Whenever it is there in the steel also different type is there. So same size different material may act different kind of response. So different types of stresses are going to develop in that particular, and also the displacements are going to change. It depends upon. So we are understanding the things, and we are going to develop the relationship between the structural members, expected internal external load, and the structures corresponding internal stresses and a displacement that occur within the member when in service. So we are understanding how it responds because of the material and what kind of size we are going to give in that particular beam or slab or column, whatever it may be. So according to that, we are understanding the internal stresses and the displacements in that particular element. So this is necessary to assure that the structural members satisfy the safety and serviceability requirement of the local building code and specifications of the area where the structure is located. So it depends. So we have and different types of codes are available according to the zone condition, earthquake zones, as per the wind conditions. So it gives whether the element or the structure, whether it is safe and the serviceability within the code we have to ensure. So then only we are going to able to understand the withstand and the serviceability, the life of the structure is going to more. Or we are going to give the serviceability requirements also. So here, so this is nothing but the structural analysis. So we are understanding the various types of structures, and we are analyzing what kind of stresses are going to develop, how the displacement is happened, and finally whether it is safe and the serviceability requirements are within the local and the based on the legality and also within the Indian standards codes. For us, IS codes are there. So within the limit, we are going to, it is there or not, we are going to check. So whether all conditions are satisfied, it is ready to design those kind of elements. That is the overall view of the structural analysis. Now we are understanding, we are into the module 1, that is introduction to arches. So first we have to understand what is definition of the arch. It is a curved structural element. Arch is nothing but the curved structural element designed to span a space while supporting loads. Unlike beam, so it is a supporting structure. It is a curved structure. It is a curved structure element designed to span a space while supporting loads, unlike beam, which primarily experiences bending stresses. And in this we have different types of stresses which are involved. It experiences bending stresses. An arch primarily transfers loads through compressive forces along its curve to its supports. So this is nothing but the definition of the arch. The first thing, it is a curved structural element designed to span a space while supporting loads. So here the primarily experiences, it is the bending stresses. An arch primarily transfer loads through compressive forces along its curve to its supports. This is the definition of the arch. Now, arches are commonly used. Where we are using these kind of arches are bridges, building and other structures where a large span is required. Whenever the large span is required, we are choose these kind of arches. The function of an arch. So it is whenever we are considering these kind of element arch. So the function of arch whenever it is to carry weight of the structure above the opening. Whenever we are considering any kind of opening. So this type of structure is nothing but the arch. So we are using this kind of structure. So whenever we are considering this kind of opening in any type of carrying. So this is going to carry weight of the structure above this opening. Whenever how much structure is there. So it is going to bear the weight of the structure. So here because of how it is bear these kind of weight of the structure above this opening, because of their shape, the block supports whenever these kind of support is there. So here structure is there, here also structure is there. So here this is the arch, it is because based on this support system, it is going to bear the structure weight. Bear the structure weight because of the blocks support each other by the mutual pressure of their own weight. Mutual pressure of their own weight. Hence the structure remains in the position by the resistance from the support. So this is the function which is involved in this arch. In this, the basic concept involved in this, an arch is purely compression form. Already we discussed, this is the compressive forces. So coming to the basic concept, arch is a pure compression form. Arch, it is a curved shape. Coming to the compression form, it can and also the large span by resolving forces into compressive stresses and in turn eliminating tensile stresses. It means it is going to eliminating the tensile stresses. This is sometimes referred to an arc action. As the forces in the arch are carried to the ground, the arch will push outward at the base. It is called the thrust. So whenever the arch will push outward the base, that is nothing but called the thrust. As the rise or height of the arch decreases, the towards the thrust increases. The outward thrust increases. So in order to maintain the arc action and prevent arch from collapsing, the thrust need to be restrained, either with internal ties or external bracing such as embankments. So whenever we are providing these kind to prevent the arch collapsing, the truss needs these is to be restrained. So for this, either with internal tiles or external bracing such as nothing but the embankments. So here this is the structure of the arch. What are the various parameters involved in this? This is nothing but the abatement. This is nothing but the abatement and various internal introuts. So this is nothing but the introuts and abatement, and also this is nothing but the extrouts. So this is nothing but the keystone. So the one is nothing but the keystone. So these are the various. So this is the 6 is nothing but the rise. So here you'll understand this is nothing but the rise. This is nothing but the rise. And this from here to here, from middle of this to middle of this, center to center is nothing but the clear span. These are the parameters involved in this arch. First we understand what is the history of these arches. So in true arches as opposite to the corbel arches were known by number of civilization in ancient Near East. So whenever whether in Mexico and different types of places, these true arches, but their use was infrequent and mostly confined to underground structures such as drains, where the problem of lateral thrust is greatly diminished. So this is, and like this, so arch of the northeast, the Levant, maybe in, so different types of arches. So in these uses of arch, so arches with circular form, also referred to as rounded arch, we commonly employed by the builders of ancient history. Heavy masonry arches are there. In ancient Roman, builders relied heavily on the rounded arch to span large open areas. The several rounded arches placed in line, end to end, from an arcade such as Roman aqueduct. So these are the various types of kinds of arches. In old ancient days they are used. This is the one of the Roman aqueduct near Nice, France. This is in France. Now, pointed arches were most often used by the builders of different types of architecture style. It is involved. The advantage of using of this pointed arch rather than a circular arch is that an arch action in a pointed arch produces less thrust at base. So this kind of pointed arch produces the less thrust at base. So this innovation allowed for taller and more closely spaced opening type. So and that is one kind of arch. Moving to the parabolic arch. So in this parabolic arch employs the principle that when weight is uniformly applied to an arch, the internal compression resulting from the weight will follow a parabolic profile. Of any arc type, the parabolic arc produces the most thrust at base but can span the largest areas. It commonly used in bridge design where long spans are needed. So like this, whenever the long span is needed, these kind of parabolic arches we are going to consider. Coming to the types of arches, it depends upon the geometry and materials of construction. In detail, we will understand this type of arches in our further lectures. So coming to these geometric arches, triangular arch, round arch, and segmental arch, unequal round arch, and also lengthened arch, equilateral pointed arch. These are the geometric arches which we are going to understand. In terms of materials, types of arches and material construction depends upon the material construction. Ashlar arch, concrete arch, wooden arch, metal arch, rubble arch, RCC arch. It depends upon the type of construction. In detail, we will see these kind of types of arches in our further classes, in next lectures. So what is the importance of an arch? So the importance of arch, because it is a marvelous way to structural support the mass of a building roof. It is going to support the mass amount, the structure, weight of that support the mass of building roof or a railway line or an aqueduct. So it is depends. So that it is very important to support the structural elements. So some of the arches built by ancient Romans still stand today, and they after a mute testament of the effectiveness of arch in engineering. So the arch is still in wide use today, and we even see big kind of whenever we are using various kinds of beams, whatever it in the shape of arches, the arch has long history in structures man has built. So in this, arches are structures composed of curvy linear members resisting on supports. So they are used for large span structures such as airplane hangars and long span bridges. One of the main distinguishing features of an arch is the development of horizontal thrust at the supports as well as the vertical reactions even in the absence of the horizontal load. Whenever the absence of the horizontal load, so here this is the one of the main distinguished feature of an arch is the development of the horizontal thrusters at the supports as well as the vertical reactions. So the internal forces at any section of an arch include axial, compression, shear force and bending moment. So the bending moment and shear force at such section of an arch are comparatively smaller than those of a beam of a span, same due to the presence of horizontal thrust. So the horizontal thrust significantly reduce the moments and shear forces at any section of an arch, which results in reduced member size and a more economical design compared to the other structures. Additionally, arches are also more pleasant than most structures. Here, these are some of the web references which we are going to understand in these structural analysis as well as these types of the arches. So, we have to understand finally what we are going to understand in these arches are curved structure. It is compressive forces are involved. And also in these types of arches, what we understand in these, for long span, we are using thrust. These are the terminology which we have to remember in these arches. So in old type of structure, how we are understanding. So these are the various types involved, various parameters involved in this arch. So in this, these are some of the references. In this, clearly we are going to understand what is meant by arch. In this reference, they are giving the interesting examples also. So many different kinds of parameters involved in this. So here we are going to understand. This is for understanding in terms of important key points we are going to consider in this particular reference. In NPTEL, in this particular reference, we make in-depth analysis about these arches. We are going to in detail each and every parameter of the arch we are going to understand using this particular reference. These are the major some of the references we are going to understand in this arches. We will discuss type of arches, how they are involved, what kind of materials based on the geometric and material, how we are defined those types of arches. This is we will see in our next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.